A, let's say for some reason that's 2. So point A is here, which means the coordinate of point A is 2,3. And suppose I have, let's say, the coordinate here of B, which is negative 1, negative 2. So the point is here. Then we're going to talk about different things. So when we join point A and B, and we want to find the distance from A to B or B to A, doesn't matter. Distance can only be positive because there's no such thing as a negative distance. This is being conical. Okay. So conventionally, you don't use a ruler to measure that distance. That's not what we do here. So there is that element of, let's suppose we say Pythagoras, right? So the theory of Pythagoras, which you should know, it says take that distance. So I'm going to call this distance delta y. That is the distance from this point to that point. So that's like 3 units up and 2 units down. So this distance here would be 5 units, whatever the units, right? Centimeters. Does that make sense? Yes. Then this would be that particular distance there. So if you were to find this distance here, which I will call delta x, the exchange in x, it's that 2 units up there. So suppose 2 is here, right? So those 2 units plus this 1 unit here. So the distance there will be 3 units. Now if you were to find then the distance of AB, you would be using the theorem of Pythagoras by squaring the sides, the sum of the sides. No? You know this, right? So I'll just say that AB would be 5 squared plus 3 squared, and then you take the square. So how do you find the values of, how do you find the 5 and the 3, for example? So the formula to find this obviously will be whatever that value is, 25 plus 9, which is 34. Are you with me? So this answer would nothing be, right? The root of 34 units. Clear? Yes. Right. So when we use this formula, we use these bars to indicate the distance between line A and B. When we talk about vectors, because this is a vector translation from here, the x direction, and then in the y direction, okay? So we can also write it as a vector. So the absolute value, the way we are going to find the distance is the way you find this 5. This 5 happens to be the exchange in y. So you take the one y value, subtract with the other y value. So it will be, I can start with x, doesn't make any difference, okay? So let's start with x. You take the one x value, say 2, minus the other x value here happens to be what? Negative 1. We square that. Then we add the sum of the squares of the sum of the difference of the sides of 3 minus negative 2. So 3 minus negative 2. You square. The square is obviously coming from there. This will be the 3 here, and that will be the 5. It doesn't matter which one you put first. Does that make sense? And then you can calculate it if you want. Something else that is important is how do you find the midpoint of line AB. Now this is simple. We are looking for the middle of this line. Okay, so that's one formula, the distance formula. To find the middle of this line, you simply take the x values, the x values of the mean of the x values. That means you take 2 and negative 1, or you can say negative 1 plus 2. It's totally up to you. So that would be like negative 1 plus 2. You find the mean, find the average. Because I started with 2, I'm going to start with 3 here. 3 plus negative 2, right? And then you find the mean. So 1 here will be the y value, or the x value, followed here by the y value. So that's going to be x, that's going to be y equal. So here, for example, you have got negative a half. Okay, that's what that's going to give you. And here you get, for this particular, that is going to be the midpoint. 2 minus, this is positive a half, and this one is also positive a half. Yes? So, when x is a half, suppose 1 is here, and y is a half. So the midpoint will be more or less somewhere there. This is not going to scale. Right, so we have now two formulas. We have the distance formula with the midpoint. Then also, if you are to calculate the gradient, the slope of this line. So I'm going to say gradient of line AB. See how I'm writing? The gradient is calculated by taking delta y over delta x. That means basically the gradient of this line would nothing be 5 over 3. You follow what I'm saying? Yes. Right? So the gradient here will be, the way you can find this, you can say, you take the y values, always remember your second coordinate. Right? So you don't get confused. Now, you can decide to start with 3 minus negative 2 all over. Because I started with that point A, I'm going to start with its corresponding x point minus negative 1. Which happens to become 5 over what? 3. Okay? Everything is positive. And the line should be positive because of the slope of this line. Remember, we are saying that when lines are going in this direction, the gradient is positive. And obviously when the line goes in this direction, the gradient is what? Negative. And here the gradient is equal to 0, and here the gradient is undefined. Okay? Because in this case, a vertical line would mean exactly two identical x values. And you may not divide by 0. Division by 0 is undefinable. You understand that? Okay, so what if someone was saying, what someone said, maybe find the gradient of line BA. That means the person is starting at point B as opposed to start at point A. So it still works delta y over delta x. So you take negative 2 minus 3. You see, you get a negative value there. And then you have negative 1 minus 2. You still get negative, but a negative by negative still gives you the same answer. Do you see that? But don't switch them around when you're calculating that. So the formula to calculate the gradient is take one value of y, subtract with another value of y. Maybe you can use 1 and 2 here. Over one value of x minus another value of x. Ultimately, there's also another one. You can also write it y. First, maybe I will write, if I cross multiply, so to speak, you understand? So y minus y sub a equals m in bracket x. Then the reason that maybe sometimes we may use this one is if we're given a point and we're supposed to write equation in the form y equals mx plus c. So we're given a point and we can also find the gradient. Then we can use. This one is particularly interesting when you want to use or write an equation in the form ax plus by plus c is equal to 0. Because sometimes the requirement might be that you leave the equation in this way where a, b, and c are constants. Okay? They can be whole numbers, negative, whatever the case is. Alright, so this is a wrap up basically of what this whole thing is all about. And then there's a few things you need to understand when it comes to lines. If I were to draw a line AB and I draw another line CD, and these lines are perpendicular to each other, and also they cut each other in half, right? It doesn't really matter the fact that they're cutting each other in half. The only important part of where this cutting comes in is when you are somehow told that the lines where they meet, the point of intersection is the midpoint. Then at that particular point, then you find half of that distance. And if that is the case, if you're told that that is the midpoint, it means that, suppose you have a midpoint, it means that both lines, they share exactly the same point. You understand? But what I want to bring in here is that the gradient of line AB multiplied by gradient of line CD should give you negative 1. In such cases, the lines will be perpendicular. It means they cross at 90-degree angles. So when we are looking at a gradient of 5 over 3, so suppose one's gradient is 5 upon 3. The other one will be the inverse of that, just with a different sign. So the other one should be negative 3 over 5. So suppose this is positive, the other one will be negative. And one will be the inverse of the other one. Such that when you multiply them, you get negative 1. This is very key in your understanding of once you're supposed to work with perpendicular lines. Right, for example, you will come across instances where you have a rectangle, right? And we are going to refer to these lines, and that concept comes in here. Then something else also, that lastly we can bring in here. There are more, but lastly, if you have what we refer to as parallel lines, it means the lines go in the same direction, and the distances between them is exactly the same. That means these lines, there's no way they're going to intersect or meet or whatever. Then the gradient of line AB, suppose this is line AB, and this is line CD, the gradients of these lines will exactly be the same. So sometimes when you're dealing with a rectangle, then these two sides are parallel, then whatever the gradient of this line is, it will be same as that. It will just have a different y-intercept. That's all. So the concept of perpendicular lines, their gradients multiplied together give you negative 1, and also parallel lines, their gradients be equal. All of this information we're going to use to solve questions relating to when we put in shapes there. Is that fine? And that is what the first try now, 15 and or 16 and 17 is basically just a recap of all of that. Where it becomes tricky is where I'm going to show you how the thing actually looks on the board. Alright, so you can get an idea. Right. So maybe we do one. Okay. Try now 17, but I would like to go to try now 18. Can I go to try now 18? You can take off. I'm going to start with try now 18. Is that fine? But before I start with try now 18, maybe we'll have a look at the example. Okay? Because that example is quite powerful. It's an extra exercise there. Okay? So all of this stuff is quite important, right? For the stuff that we're doing. There will be instances where the requirement will be for you to use vectors or all these concepts in order to find a particular thing, what they are looking for. Or even to come up with equations to solve one.
So, find the maybe you can do equations.
Exactly. Let's look at try now 18. The point C lies on the perpendicular bisector of the line joining points A and B. Now let me just write down. So this is page what? 128. So I'm given 2 points. Point A being 4,6 and point B being 10,2. Then they are saying the point C lies on the perpendicular bisector of the line. So this line, when we draw it, point C lies on the perpendicular bisector. The word bisect means to cut in half. Alright?
So let's find the point.
Cut in half. So if this line was this way, so point C, maybe our A is here and B is, well, 10, 2. Let's say our B is here and our A is here. So point C lies here, and there's going to be another line that comes over here to make like so. This point C is the midpoint. You understand that? Then they say C also lies on the line parallel to AB. So let's first determine what point C would be.
The midpoint.
So C is the midpoint. So to find the midpoint, you take the two values, x values, you add them together, half of them. Two y values, you add them together, half of them. So that point C would be 14 over 2, that's 7. That's 8, that's 4. Is that making sense? That's our point C. Right? Also lies on the line parallel to AB. So when we have a line parallel to AB, let us first, we know that the lines that parallel lines share the same or their gradients are equal. So that means I can find the gradient of line AB. So let's find the gradient of line AB, which means no need for the bracket here. So we take delta y, 6 minus 2, over 4 minus 10. So that's going to be 4 and negative 6. Therefore, negative 2 this. Am I correct? You agree?
But we have to find.
So this line that we are looking for will be y equals to minus 2 over 3x. But we have a problem. We don't have a point C, which is the where the line will cut the y intercept. But then they are giving us another point 3 equal by 11. Mm.
So how to find perpendicular? What is the gradient?
So yeah, we found the gradient. We have the midpoint.
Yeah, but the gradient.
Okay. We are also first. Let's do it step by step. The first question says find the equation of the perpendicular bisector. All right. So we are looking for the equation of this dotted line, by the way. So the equation of that line is going to be part A. That's going to be y equals to. So we know what the gradient is here of this line. So gradient of this one will be 3 upon 2x plus c. Does that make sense to you? But now for this perpendicular line, right? So the gradient will be positive, the other one will be negative. In fact, the way I do that is the other way around, right? Okay? This will be my line AB, and that will be the line that I'm looking at, because the gradient of this line, AB, should be negative. Lines that have negative gradients don't go in this direction. But this is just a sketch, so it will be the other way around. Okay, so I'll switch that around. So how do you find this point C here? Because the question wants you to find the equation of the perpendicular bisector. You have to substitute the midpoint, right? Because the midpoint is a common point to the line and its perpendicular bisector. Does that make sense? Since it's a common point, you are going to substitute the midpoint, the point 7, 4, 4x and 4y, in order for you to find the value of C. Right. So y is then 4. This is 3 halves. Then you multiply that by what? By 7 plus 6. So this is 21 upon 2. Right? When you are adding 21 upon 2, you subtract. Right? So that is going to be C equals to 4 minus 21 upon 2. 21 upon 2 comes from 3 times 7 is 21 divided by 2. And I'm subtracting because it's going to be positive, so when it goes over, it comes to minus. Alright? Is that fine? LCM here is 2. So this is going to be 8 minus 21. Okay? So what is 8 minus 21? It's minus what? Over? Over 2. So what is my equation? Therefore my equation is, what's the gradient?
3 upon 2.
So it's 3 upon 2 of x minus 13 half. So this is the perpendicular bisector. That's part A. Part B, I'm continuing from here. They are saying calculate the coordinate of C. But we have already determined the coordinate of C. Did we determine the coordinate of C?
So C lies on.
Right. C, here's the problem. My diagram, this is not what it means. C lies on a line on the perpendicular bisector. So, however that perpendicular bisector looks, C can be anywhere. And also, C also lies on the line parallel to AB. So, when a line is parallel to AB, then those lines must have exactly the same gradient. What is the gradient of AB? The gradient of AB we calculated to be minus 3 upon 2. So for us to find the point C, we are going to substitute the point 3, 11. Because that point 3, 11, right? It lies on the line that is parallel to this line. Y equals minus 2 over 3x plus C. Simply the same gradient. But C is not the midpoint, right? Here we calculated the midpoint in order for us to find the equation. Right, so we're going to substitute for x and for y. So that means 11 minus 11 equals to 2 upon 3 times the value of x, which happens to be 3. So these 3's cancel, leaving you over 2. Adding that gives you 11 plus 2 will give you C. Therefore, C is equal to what? 13.
So the equation is?
So the equation would be y equals to minus 2 upon 3x plus 13. I don't have to show that visually, right?
But they are asking for the coordinate.
Okay, my bad. They are asking for what?
The coordinate of C.
The coordinate of C. How would you find the coordinate of C? So first of all,
Wait.
C lies on the line that is parallel. We now know the parallel. C also lies on the line that is perpendicular. We have this. So we take these two equations and we equate them. Then we get the value of x. Then we take the value of y and substitute in either this equation or that to find the coordinate of x. So I'm going to do that here, right?
Yeah.
So take the two equate. So there's a lot to it, huh? Not really. So I'm going to take 3 over 2x minus 13 upon 2. That is equal to 2 over 3x.
Minus.
No, but that one is plus 13. That one
So minus again.
minus 2.
It goes over.
So all terms containing x one side.
One side.
So these two terms come together. So I'm letting these two equations be equal. If each one is y equals to, then the two equations are equal. So that's going to be 3 halves of x minus 2. That becomes plus of x equals to 13 plus 13 upon 2. Please don't be afraid working with fractions. Okay? Like this. You understand that? Here.
13 over 6.
That becomes positive. Yes? 6.5 here. 6.59. I'll give you 19.5. Are you with me? 1.5x plus that negative 0 or positive 0.
13 over 6.
Goes on. Right. LCM here.
13 over 6.
LCM here. That's 9
13.
plus 4. 13x.
Yes.
When you are finding LCM here, it's 26 plus 13. 39. Now you can do cross multiplication. Or you can multiply here by 3 so that the LCM are 6 and then you drop them.
X is 9.
Yeah? Or you can do cross multiplication. It's totally up to you.
X is 9.
Okay? So I'm going to be left with here 13x equals to 39 times 3. 19 plus 27. 90 plus 27.
X is 9.
117.
X is 9.
X equals to 117 divided by 3. Alright, so now we have our x then. Right?
This is 9.
Now we can calculate the y value
Just substitute.
by substituting this x equals to 9 either this equation or that equation.
The first one.
Running the substitute in this equation. Okay? Therefore, y equals to 3 halves of this 9 that we have calculated now,
27.
minus 13 over 2. And what do you get here? 27.
The answer is 7.
So, the gradient or the point C will be 9,
9,
comma
7.
7.
First question.
Will be the first part. So far so good?
Of course.
So far so good? There's a lot in there, okay, that you need to do. Right, I'm going to bring in one question. Question 2, because I have to do question 2, right? Can I just
How are we doing?
running away from it. Someone will come and do the report, or should I continue?
Okay, volunteers.
Are you still writing here? I'll give you 2 minutes to finish taking down everything. So far, so good. So you know that you have all those formulas. Now you must put them to good use. Okay? It's not always they're going to ask you a straightforward question like, what is the midpoint? What is the distance? You need to do something. This is 3 out of 3. What are you doing right now? You must just check the time, so we can make sure that I don't miss the vehicle's call. What is in the box that you're going to get the other day? No? Where's the box? Not this one. No, but this is not the box one. Where's the box? Is it this one? And I think I only just like, this was the box that was school, man.
Not easy.
No. Hey, what did you do with the box of chalk? That was the only one that was here, right? If I have to send you again to go and ask for chalk, just tell one thing, this is a joke. What are you guys doing with chalk? In their class. Okay, let's look at question 2. Okay, you can solve that equation the whole way, right? Cross multiply or. Right. If I see you're getting tired, I'll go longer and longer. Plural of the point. Coordinates means the a value, x value, and the y value, right? At which the perpendicular bisector cut in half, 90 degrees. Of the line joining the point 2,7 and the point 2, 10, what is it? 3. See? That's an interesting way of writing that. Meets. Yeah.
C. I goes to
I think you know your job. Come on. Yeah, you get people trying out 16. Try out
17.
Right, so just read this question nicely. You're supposed to find the coordinates of the point at which the perpendicular bisector of the line joining 2,7 to 10,3 meets the x-axis. When something meets the x-axis, at that point, y is equal to 0. So this is the line 2,7 to 10,3. So 2,7 to 2,7 to 10,3 will be a line that is somewhere there, right? We want to find where that line cuts the y, the x-axis. So what is it that you need to do? We need to find the gradient. And also find the gradient. We actually need to find the equation of the line. And once we find the equation of the line, we let what equal to what. Because we know at this particular point, look, we know that we're looking for a value of x, whatever the y value will be equal to 0. Is it not? So it's just, what is that particular value of x? You follow? I'm using a different letter here. I don't want to use x. But you get the idea. So whatever that value is, we are looking for that value of x. So we're going to substitute this into the formula to give us that value. Right, so we can calculate the gradient first. So what is the gradient going to equal to? Delta y, delta x. I can start with 7 minus 3.
It's a negative gradient.
It's a negative value. 7 minus 3 upon 2 minus 10. That gives you 4. 7 minus 3. And 2 minus 10 gives you negative 8. So it's negative a half. Yes? Then if I have the equation negative a half, I hope you still remember the formula. What comes in? X minus. So I can use any point. I can use this point or I can use that point. That makes sense? So if I use this point, then it's going to be x minus 10. It's minus, no? So if it becomes a negative 10, it becomes positive. And on this side, it's going to be y minus 3.
You're using the other one.
I'm using the other formula because I want the equation in the form ax plus by plus. Then I make y is equal to 0. Or you can use whatever. This, you can write it in the form y equals to mx plus c.
Yeah.
Substitute one of the points, you get the value of
Or you
c.
can just find the midpoint.
And then you make y
You need to
0.
find the midpoint.
Good. Now, we are looking at the coordinates of the point at which the perpendicular bisector
You can't-
of the line. Now, perpendicular bisector means that point is, yeah, what?
The point they're
It doesn't
sharing.
get,
They're sharing.
they are sharing. Common point. What am I calculating when I do that? Nothing.
The equation of
At which the perpendicular bisector. So, whatever that line is, this line, when you draw it, you realize it's the line that goes this way. We're looking for a point such that the perpendicular axis, the coordinates of the point at which blah 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 meets the x-axis. What does that say?
we need to find-
Why is this part in here, the perpendicular bisector?
Because we are looking at the particular, not the
Good.
equation
Of the line. Joining this, we are looking for the perpendicular line. Right. Not the other one. This two to set this point here, 2.7 to 20.3. On which line are they?
Yeah.
I'm going to repeat the question because they're thinking. Find the coordinates of the point
We can say.
at which the perpendicular bisector of the line joining 2.7 to 10.3 meets the x-axis. Which line are we talking about? Are we talking about the line? This line here, or are we talking about different lines? Why did they give us this particular part
Find the
of the
perpendicular.
sentence?
Find the midpoint. They give us the 2 points to find the gradient in the midpoint.
Okay, so we have the gradient,
And we need to find the midpoint.
so we need to find the midpoint. Why should we calculate the midpoint?
Because we don't know the coordinates of the perpendicular. The line, the coordinates of lies in the perpendicular.
What did you say?
We don't have a coordinate that lies in the perpendicular. On the perpendicular line. This one's are just.
Okay, I'm going to find the midpoint.